This video is on thermodynamic tutorial questions. You can refer to the tutorial question given to you, the same set. So let's look at the first question. So the first question is asking you to state the first, second, and third thermodynamic law. So I think you can just refer to the reference book or lecture notes to answer that. So let's look at the second question. A 5-gram mass of a metal was heated to 100 degrees Celsius and then plunged into 100 grams of water at 24 degree. The temperature of the resulting mixture became 28 degrees. So we take out all the informations here, the mass of metal, the change of temperature of metal, water mass, and the change of temperature of water. So the question A, determine the energy absorbed by the water. So energy absorbed by the water, we use this formula, which is heat equal to mass times specific heat capacity for water. We can find out, all right? And the difference in temperature, which is 4 Celsius, 28 minus 24, okay? So in the end, you will get a value, and that is let me name it as X joule. Remember, the unit must be suitable, a gram, Celsius, and joule. Now, the next thing is determine the heat capacity of the metal. So now, what is heat capacity? So the heat capacity is C, capital C. So the heat capacity Q, remember Q is equal to C times delta T, okay? So now we know that the heat from the metal, which is thrown into the water, and the heat from the metal is transferred to water, and the heat absorbed by water is determined in A, question A, and we know that the total heat is X, okay? You have to calculate it by yourself, and from here, you can calculate the heat capacity of that metal by dividing X with the change of temperature of the metal, which is 100 degrees. So I name it as Y, joule over Celsius. So this is for B. And let's look at C. C determines the specific heat of the metal. So this is the relation between heat capacity and the specific heat capacity of the metal. So we can use the value of C, which we obtained from question B, right? And divide with the mass of the metal. And finally, we will get the specific heat capacity of the metal. Now let's look at the next questions. Thermochemical equation for the reaction of carbon monoxide with oxygen is given here. And the question is asking, A, write the thermochemical equation for the reaction using 2 mole of carbon monoxide. So we have to change it to 2 mole of carbon monoxide. So we have to divide the equation given with 2 over 3. For all reactant and product, okay, we have to times with 2 over 3 to cancel out the 3, so we get the final equation to be after being times with 2 over 3. And the same thing has to be done with the value of delta H naught here. And we can see after times with 2/3, this is the new value. And this whole thing here, the chemical equation and the value of new delta H is what we call as the thermochemical equation for the reaction using 2 mole of carbon monoxide. Now look at the next question B. What is the delta H for the formation of 1 mole CO2 by the reaction? So if you look at the original reaction, the mole form, the CO2 mole form is 3. But the question is asking if how are we going to calculate if we want to have 1 mole of CO2. So the whole equation has to be times with 1/3. Okay, and this is the new equation. And the delta H also must be divided with 3. So this whole thing will be the new thermochemical equation for 1 mole of CO2. Right, next question is calculate the standard free energy, Gibbs free energy, delta G, for the formation of methane from carbon and hydrogen at 298 Kelvin using tabulated values of delta H and S. Is the reaction spontaneous under standard condition? So based on the data given to you, first you have to know, of course, the right formula or the right equation. And then in order to put all the values inside the equation, we have to calculate delta H, okay? So using Hess law, total delta H of the product minus the total delta H of the reactant, okay? You can see where's the product, where's the reactant from the table, okay? Right? And then same goes to delta S, okay? You have to calculate the delta S, which is total of delta S of product minus total delta S of reactant. And then remember about the stoichiometric coefficient, okay? Because in S, okay, the hydrogen is 2. Okay, if you look at the reaction, the hydrogen is 2. So you must make sure that you times 2 for this value. Hopefully my calculation is correct. Okay, so we total up everything and put this in this equation. All right. And make sure the unit is similar to each other. You can see that from delta H, the unit, if we calculate, is in kilojoule, but the unit for entropy, S, is joule. So you have to make it compatible to each other. You have to change the unit. So after changing the unit, you can calculate delta G. So I got a negative value. So the reaction is supposed to be spontaneous because it is delta G is negative. So look at question 5. Use enthalpies of formation to calculate the value of delta H naught for the reaction below. So if you look at the question, there is a bit of mistake. So I try to rewrite back the chemical equation. And you are also given enthalpies of formation. So the first thing is to calculate the value of delta H naught. So using Hess law, you the total H naught or delta H naught for the product minus the total delta H naught for the reactant. Okay, and why it is 0 when you have the same, when you have oxygen molecule, for example, hydrogen molecule, then the delta H is 0. You can check in the value in the reference book that the formation of a molecule of gas, okay, the same atom, for example, oxygen O2, hydrogen, H2, chlorine, Cl2, or any other the same atom forming a molecule gas, the heat of formation or the enthalpies of formation is 0. So after the calculation, I name the answer as A kilojoule per mole. Okay. So now the next question is calculate delta E at 298 Kelvin for the above reaction. So for this, you have to remember this one. Delta E equal to Q minus W, or it can be Q plus W. Okay, in this case, we have to think about it's a gas, it's a production of gas. Okay, it's a you can see that the reactant is also in the form of gas, and then the product also has gas and liquid. So we can rewrite this equation. Okay, delta H naught minus or plus depends on the work done, or the work is done by the system, or the work done on the system. And we can do delta N, we can calculate delta N, which is the mole of gases of the product minus the mole of reactant of gas of the reactant. And you can use this formula, delta H naught minus delta N times R times T. So R is 8.314. Okay, make sure that you know the right unit. And T is 298 Kelvin. And by right, the mole difference is negative. So this is actually whether this reaction is correct or not, because the question is a bit of missing information in the original equation. So let's just try it. If it is a negative, means that the mole of gas of reactant is greater than the mole of gas of product. So there is a possibility that the volume will be less compared to the original volume before the reaction. So let's just try. If you put all the values here, then you might be getting this. A from the first, which is delta H, that is obtained from A from the first question. And then 5 is the mole difference, R value, and then the kelvins. All right, should be getting the final answer.